In this video I'm going to show you how to solve equations like this one, and for cos and tan as well, and for degrees and also radians. And I'm going to show you how to do it if they ask you to solve for theta to the nearest minute. And I'm going to be showing you how to use this Casio, and also I've got an HP and a TI, so I'll show you how to do all these things with several different models of calculator. Now, the first thing you want to do when you're solving trig equations with a calculator is make sure that you're in the right mode. So we're looking for an answer in degrees. Now, the way that you tell if your calculator is in degrees is, for this model, there will be a little D there when it's in degrees mode. Now, at the moment, I've got an R, a little capital R. That means it's in radians mode. So I'm going to have to switch it into degrees. So the way you do that on this model is you want to go to setup. So I'll hit shift setup, and then you can see degrees is number 3. So I'm going to hit 3, and now I have a little D there. So now it's in degrees. On the HP, it's kind of similar, where there's a little D there if it's in degrees mode. If you've got an R there instead, then you'll need to go to mode, hit mode again, and then hit 1 for degrees. And now you've got a D there. For the TI, it actually says DEG there, so that's in degrees. If it didn't say DEG, if it said rad for radians, you would go to mode, and then you can use the arrow keys to select. So if I hit enter there, it's going to switch it to radians. I'll switch it back to degrees. And now it's in degrees. Once I've done that, what I would do is draw the unit circle, so we can get an estimate for the solutions and see what quadrant they're in. Because there's a lot of things that can go wrong when you're doing these on a calculator. Like, apart from it being in the wrong mode, you might just type something in wrong, and it's really good to have that estimate so that you know if you've done something wrong. So if you haven't seen my previous video where I covered solving trig equations with exact solutions, you might want to watch that first. But for this one, you've got sine theta equals 0.2. So sine is the y-coordinate, so we go up to roughly 0.2, which is around there. And just draw in a horizontal line like that. And then where that cuts the unit circle is the two solutions that we're looking for. So, I mean, that looks like maybe 10, 20 degrees. So we could estimate theta might be, let's say, 10 degrees, or it might be 180 minus 10, which is 170. So it's good to kind of have that estimate in the back of your mind so that you know if you've done it wrong. But what we can do to work out what it is exactly is you need to use this sine to the minus 1 button. Now let me just explain what that means. So if you've done function notation before, you might be already familiar with that. Like if you do f to the minus 1 of x, you might have seen that before and know what that means. Otherwise, let me just explain why they use that notation. So if you had something like some variable times theta equals 0.2, you could solve that by dividing both sides by a. Now, dividing by a is the same thing as multiplying by the reciprocal of a, which you can write as a to the minus 1. So it would be a to the minus 1 times the 0.2. So when we solve an equation like this, where it's got sine theta equals 0.2, sort of with, in analogy with this, we say that theta equals sine to the minus 1 of 0.2. Now, I just want to point out that this isn't literally the reciprocal of sine, because that doesn't even make any sense. Like, the sine here isn't a variable, it isn't a number. It's actually a function. It's sine of theta. It's not sine times theta. But they use this notation because it's kind of analogous to this. But it doesn't actually mean 1 over sine. It's sometimes called arc sine. So you might sometimes see it written as arc sine of 0.2, or it's also sometimes called inverse sine. Now, the way to solve that on the calculator is to get sine to the minus 1, we go shift sine, and then type in the 0.2, and then that tells us 11.5. Now, it can only tell you one of the solutions, it doesn't know which one you want. So that's just going to be this solution. Now we need to round that to the nearest degree, so that would be 12 degrees. And then to work out the other one, it's just 180 minus 12. So let's type that in. You can just go 180 minus the last answer. So 168. Now it's more or less the same on the TI and HP, so I'm not going to show you those as well. Alright, let's have a go at cos theta equals negative 0.6. Now if you want to give this a go for yourself, then pause the video here. Alright, first thing I would do is draw the unit circle. Cos is the x coordinate and it's negative, which means we go left by 0.6. So around there, and draw that in, and then we can see these are the angles that we're looking for. So on the calculator, we can go inverse cos of negative 0.6, and that gives us 127 if you round that off to the nearest degree. Now to work out the other one, if they said negative 180 to 180, you would just say negative 127. But in this case, to get it into that range, what you can do is add 360 to negative 127. So the easiest way to do it from here is just go 360 minus ants. And that will give you 233 degrees. And that's it. Alright, let's try tan theta equals negative 2. So what I would do is draw in the unit circle. Now for tan, what you want to do is draw in this tangent line. And then this is the y coordinate on that line. So we go down to negative 2, which is around there. And then you want to draw a line through this point and through the origin. And just send it straight through the circle. And then these are the two angles that we're looking for. So this one looks like maybe 120 degrees-ish. And this one is maybe like negative 60, which would be 300 in that range. So that's, again, really useful to have those estimates so that you know if you've made a mistake on the calculator. So to work them out exactly, we want inverse tan of negative 2, and that tells us negative 63. So the calculator doesn't know what range you want the answer in. So to get it into that range, we would have to add 360. And that tells us, to the nearest degree, that would be 297 degrees. So that's that one. Now to work out the other one, think of it like that is 180 degrees. So if we just subtract 180 from that, that'll give us the second answer. So let's go minus 180, and that tells us 117 degrees. So that's how you solve that one. Alright, sine theta equals negative 0.9. This one may be a tad trickier than the other ones, so I don't want to deprive you of the challenge of working this one out. So pause the video here and see if you can figure out the solutions to that. Now, first thing I would do is draw the unit circle. And we've got a y coordinate of negative 0.9, so let's go down here. And then these are the two angles that we're looking for. So we might expect, that looks like about 70 degrees maybe, so we're expecting it to be like maybe 180 plus 70, so 250 degrees-ish might be one of the solutions. And then the other one is like 270 plus 20, so 290. So it's really good to have an idea of what we're looking for first. Now let's try arcsine of negative 0.9. Oops. 9 makes negative 64. Now that's not in the range we want, so maybe we can add 360 to that. So 296 is one of the solutions. Now, to get the other one, there's actually a lot of different ways that you can do this. I'll just show you a couple ways. Maybe what we can do is go back to what we had before. Take that 360 off again. So negative 64. Now, if you think of that as like 180 plus the 64, that's like 180 minus negative 64. So you can go like 180 minus ants, and that will give you the other one, 244 degrees. Another way to do it, which might be a bit easier actually, is not to work out that angle directly, but actually to work out what this angle is as a positive angle. And the way you can do that is go arcsine of positive 0.9. And that tells you what's called the principal angle, which is like that angle and that angle. They're both 64. And then you can go, 180 plus that is going to be that one. And let's just get rid of the 180 again. And then 360 minus the 64 is going to give you that one. So 360 minus that one, 296. So that's a couple ways to do it. You might also have done something completely different. You might have done something like arcsine of negative 0.9, and then maybe you did 360 plus that. And then maybe you thought, well, to like flip it over to there, we do 180 minus that, right? So let's try 180 minus that. And then, oh no, that's not in the right range. Let's add 360 to it. So you've got all sorts of different ways that you can do it. Now, I don't want you to feel like you have to like memorize one procedure and sort of lock into that, because the more you memorize, the less you understand. I think it's better to just stay flexible and just use your creativity to come up with the solutions. You'll know if you've done it right if it looks like your estimates that you did before. Now let's see what happens if they ask you to solve it to the nearest minute. So first, I just want to give you some historical context for that term minute, because you might be confused, like, isn't that a measure of time, not angle? Well, when they were first dividing the hour into little parts, they called the first division pars minuta prima in Latin, which means first small part, and that was a 60th of an hour. And then they wanted something smaller than that, so they called it pars minuta secunda, the second small part. Now, it gets a bit annoying saying that phrase over and over again, so they abbreviated this down to minute and this down to second. And it's minute as in minute, as in small. So that's where that word comes from. And it's actually not just for time, it's also for other things like angle. Just wherever you need something to be divided into 60 parts, you might call it a minute. And then if you want something smaller where that minute is divided into 60 parts, you call that a second. So for example, if you wanted to write like 32.5 degrees, you would say 32 degrees, and then half a degree would be 30 minutes. So you write that. Now, you write that with a little, what's called a prime symbol there. So they use prime as in, like prime as in first. So the symbol for that was prime, and then for second is like that. I mean, they're basically just tally marks. You'll also see these in calculus. When you get to calculus, you'll see like f prime of x meaning the first derivative, and that meaning the second derivative. Now these days we pronounce that double prime, but back when they were sort of inventing this notation, they would have actually said f second for that, because that's literally what it is. It's like a 2 there. Now to solve the equation, let's draw the unit circle. We're talking about cos, so that's the x coordinates. So we go to x equals 0.3, draw that in, and then these are the two solutions that we're looking for. Okay, now let's go inverse cos of 0.3. Okay, so that's, if we were answering to the nearest degree, that would be 73 degrees. But if we're answering to the nearest minute, there's a really helpful button here. You can see the symbol for minutes there, so that says degrees, minutes, seconds. So you can just hit that button, and that will convert it into degrees, minutes, and seconds rather than as a decimal. So we've got 72 degrees, and now we have to round this off. So we have to decide if this is less or more than half a minute. Now remember that there are 60 seconds in a minute. So half a minute will actually be 30 seconds. So this is more than half. So we actually have to round that up. So that would be 72 degrees, 33 minutes. If they asked you to do it to the nearest second, you would say 72 degrees, 32 minutes, and we'd round that off to 33 seconds, like that. Okay, so that's that one. Now, if they said negative 180 to 180, you could just call this negative 72 degrees, 33 minutes. But since we need to be in this range, so we can't have negative answers, we can go 360 minus that. So 287, except we have to convert that into degrees and minutes, so we hit the button for that. And we can see that's 287 degrees and 27 minutes. You'd round that one down because that's less than 30. Okay, so that's how you do it on the Casio. On the HP, it's basically the same, but on the TI, it's a little bit different. So you type in arccos of 0.3, enter, and then to convert that into degrees, minutes, and seconds, you need to go to the angle thing here, so second angle, and then if you scroll down, at the bottom you'll see one that says DMS. Now that stands for degrees, minutes, seconds. So we want to select that one. You don't actually have to scroll down each time, you can just press 6. You can see the 6 there is DMS. So that converted to DMS, hit enter again, and that will tell you 72 degrees and 33 minutes if we round that off. Okay, and then to work out the other one, we go 360 minus ounce, per second ounce, tells us that, and then we have to convert that again. So angle, and then I'll just hit 6 this time, and that will convert that. So 287 degrees, 27 minutes. Let's try one in radians. So let's first draw the unit circle. For tan, you want to draw that line in, and then go to y coordinate of 0.1. So around there, and then connect that with the origin, and keep going. So there's the two angles that we're looking for. So maybe 10 degrees, and except that we're not working in degrees, we're working in radians. So some small angle, and then something a bit bigger than pi, so like 3.2 maybe. Now what we need to do is change this into radians because it's in degrees at the moment, so you're set up and radians first. Okay, and then we can go arctan of 0.1, 0.099. So if we want to round that to 2 decimal places, that means we want to like cut it off there. So that gets rounded up to like 10, so it's actually 10. Let's say theta equals 0.10 would be the first solution. And then to work out this one, because this angle here is 180 degrees, or pi, if we're working in radians, what you can do is just add pi to that answer, and that will give you 3.24. So that's how you answer that one. Let's try sine theta equals negative 0.7 for theta between negative pi and pi. So pause the video here and see if you can figure it out before you watch my solution. Now the first thing I would do is draw the unit circle. Sine is the y coordinate, so we go down to negative 0.7, which is there. So now we know what quadrants we're looking for. That's really helpful. Let's go to the calculator and go arcsine of negative 0.7. I'm still in radians mode, so that's fine. Now that's all right, because now we're in the range negative pi to pi. Otherwise you'd have to add 2 pi to it to get it into the range 0 to 2 pi, if that's what they were asking for. But for this one, it's fine to answer negative 0.78, that would be, if we round it to 2 decimal places. Now to work out the other one, what you could do is go, well, pi minus that is sort of how I think of flipping that over, but the problem with that, let's try that. The problem with that is that's now outside of the range we want. That's actually describing it as like going around that way, pi and a bit more. So what we'll have to do to get it in that range is subtract 2 pi from it. So you might notice that, you know, this minus 2 pi, an easier way to do that would have been negative pi minus ounce, which also makes sense. So if you thought of that, that's fantastic. But it doesn't really matter as long as you get there in the end. So negative 2.37 would be the answer to that one. Let's go back to degrees. Let's solve tan theta equals 3 for theta between negative 180 and 180 to the nearest minute. So pause the video here to figure it out for yourself. Now what I would do is draw the unit circle. For tan, you want to draw in a tangent line, and then we want a y-coordinate of 3. So if that's at 1, you want 1, 2, 3, and then connect that to the origin. So these are the two angles that we're looking for. Maybe something around 70 degrees, and then this would be like maybe negative 110, if we want it in that range. So let's try that out exactly. Arctan of 3 will tell us that. That's good. And then if we want it to the nearest minute, we hit that. And we've got 71 degrees. And then we have to round it up because that's big. So 34 minutes. And then if we want to work out the other one, if you were doing 0 to 360, you would add 180 to get around there. But since we want to express this as a negative angle, what we can do is subtract 180. So there's no need to like memorize these things. You can just kind of like look at the diagram and figure it out. Use your creativity. It's the best way to do maths, I think. And then we need to put that into minutes and seconds. So we've got negative 108 degrees. And so that's less than 30, so we round that down to 26 minutes. In the next video in this series, I'll be covering slightly more complicated equations like this one, and also general solutions to trigonometric equations. So check that one out. And if you enjoyed this video, then give it a thumbs up, and let me know in the comments if you still have any questions.